The topic of the day is trigonometric identities, but we're going to start with a little review. We're going to simplify this algebraic rational expression. In other words, get it to its lowest terms. In order to do that, I'm going to take in factor like we normally would, pull out greatest common factor, 2x, left with x squared plus 6x, I lied, plus 3x, whoops, plus 2, or pull out a 5x, left with x plus 1. Factor the numerator a little bit more. 2 binomials, x plus 1, x plus 2, over 5x times the quantity of x plus 1. And we know that anything that has common factors top and bottom reduce. X's go as well. I'm left with 2 times the quantity of x plus 2 over 5. Now, this quantity here is said to be an identity spelled that all wrong, but an identity for the initial problem. In other words, it's an equality. We're going to look at trigonometric identities. The ones we know at this point are the ones for sine, cosine, tangent, cosecant, secant, cotangent, and regular tangent. We know that cosecant's 1 over sine. We can also say, even though we don't do it often, we can say that sine is equal to 1 over cosecant. 1 over cosine is secant, so cosine is equal to 1 over secant. Tangent is, or cotangent is the reciprocal of tangent, so likewise, tangent's 1 over the cotangent. And finally, tangent is the sine over the cosine. And if we wanted the cotangent, we could say that's cosine over sine. So those are our basic identities that we already know. Now, we're going to look at something we've become used to with our circle. We know that the general equation for a circle is x squared plus y squared is equal to 1 if we have the unit circle. Therefore, since we are talking the unit circle, we know that the cosine is equal to x, the sine is equal to y. So I'm going to make a substitution and say that the sine squared of x, substituting for y, plus the cosine squared of x, substituting for x, is equal to 1. If I know this, I can create another identity from that by dividing each term by sine squared. As you can see here, I get 3 new quantities. I get 1 plus the cotangent squared equals the cosecant squared. Great, there's another identity. Again, I can start out with sine squared plus cosine squared is equal to 1 and divide everything by cosine squared, thus getting another identity. Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. After we get done with all these, we have what are called our 3 Pythagorean identities. These you need to know well. So we have our base, sine squared plus cosine squared is equal to 1. And then our other 2 that we got from either dividing by sine squared or cosine squared to each and every term. So 1 plus cotangent squared is cosecant squared, and tangent squared plus 1 is secant squared. Now, if we have these 3 Pythagorean identities, we actually have a lot more. And we can see that by just subtracting quantities to each side. Let's start out with the simple sine squared plus cosine squared is equal to 1. If I subtract cosine squared to each side, then I get sine squared equals 1 minus cosine squared. If I subtract sine squared to both sides, I get cosine squared is equal to 1 minus sine squared. And so on and so forth. You can see what I've done in each of these 3 cases. You need to be able to manipulate all of them. Again, the big 3 are the important ones, these 3 Pythagorean identities. Now, what we're going to do is we're going to use these identities to simplify trigonometric expressions. we have the cosecant of x is equal to 1 minus the cosine squared. We just got done talking about this quantity here. That's a Pythagorean identity. So we have the cosecant of x is equal to, well, 1 minus cosine squared is the same as sine squared of x. Now, if I want to simplify this even more, it asks me to simplify this to one function, then I need to be able to reduce something. I know cosecant is 1 over the sine of x. Now, if I have 1 over the sine of x times the sine squared of x, and if it helps, I can put that over 1, I know that any like factor reduces, so I'm left with the sine of x. So you can see I reduced a complicated function into a simpler function. It's much like simplifying our initial problem algebraically into a simpler algebraic fraction. But this is a trigonometric function, so we're just simplifying these. Okay, let's move on. Have a little more difficult problem here, but again, these look like Pythagorean identities. 1 plus cotangent squared is cosecant squared, and 1 plus tan squared is secant squared. Now, granted, this fraction is simpler than this fraction. We had 4 terms here, now we have 2 terms here, but it can probably be simplified even a little bit more. I know that cosecant is 1 over sine. So I can say cosecant squared is 1 over sine squared. Likewise, secant is 1 over cosine. So I can say secant squared is 1 over cosine squared. Now I have a complex fraction. I can multiply by the reciprocal. This is the same as 1 over sine squared multiplied by cosine squared, which gives me cosine squared over sine squared, which simplifies to cotangent squared of x. And this is our simplified version of the original fraction. Again, we're just simplifying terms. So in this case, we have no Pythagorean identities. So what I like to do is, if I don't see anything right off the bat, I'll change my quantities to versions of sine and cosine. I know cosecant is 1 over the sine of x. Cosine is just cosine. And cotangent is the cosine over the sine. Now, I look at this and say, well, I have fractions and I'm going to be subtracting. I better have a common denominator, and I do. I have 1 minus cosine times cosine is cosine squared all over the sine. Now you'll notice I have this term in the numerator. That's actually a Pythagorean identity. 1 minus cosine squared is sine squared, and sine squared over sine is just equal to the sine of x. So that's my simplified version of the initial fraction. Let's move to the next example. The only way you're going to get good at these is to do lots of practice and know your Pythagorean identities and your regular trig identities. So here we go. I know 1 plus tan squared is a Pythagorean identity. 1 plus tan squared is secant squared, so I have cotangent times secant squared of x all over the tangent of x. Now, I look at this and I say, well, hey, wait a minute. Isn't the cotangent 1 over the tan of x? If that's true, then I have the secant, which is 1 over cosine, I'm going to make it squared since I have secant squared, over tangent. If I have this quantity, now I know that 1 over cosine squared is over tangent squared. But this doesn't look like it's going to reduce very well. But let's take a look. I know a tangent squared has a cosine in it somewhere, because tangent squared is the same as sine squared over the cosine squared. Now, if I change this complex fraction into a multiplication of the reciprocal, I have 1 over cosine squared multiplied by cosine squared over sine squared. You'll notice in this case that the cosine squareds are just going to reduce. If the cosine squareds reduce, that leaves me with 1 over the sine squared. But that reduces. Since I have 1 over sine squared, that's a reciprocal to cosecant squared of x. And that is my simplified term. Let's move on to the next example. Again, I see that I don't have any options for Pythagorean identities. So I will go ahead and change the tangent, because that's really the only thing I can change, to sine over cosine. Now you'll notice I have the cosine of x plus sine squared of x over cosine. Now, I could do a couple of things right now. I notice I have sine squared, and I can make that into a Pythagorean identity. But what I'm really going to have to do is notice that I have an addition here, and I have a fraction on the right side. In order to add things with fractions, I have to have common denominators. So what I'm going to do is I'm going to take and multiply this cosine by cosine over cosine so that I can have a common denominator. In doing so, I get cosine times cosine, which is cosine squared of x, over cosine, plus sine squared of x over cosine. And I notice, well, hey, cosine squared plus sine squared, that's a Pythagorean identity. That's just 1 over the cosine. And I know 1 over cosine is equal to the secant. And that's my simplified form of the original. Again, it's going to take some practice to start picking some of this stuff up. You're going to have to know those Pythagorean identities very well. Let's continue. So now I have a situation where I have two terms being multiplied together, and I have some options. If I know there is a Pythagorean identity, I might want to use that. But 1 minus cosine is not a Pythagorean identity because it has no squared term on it. So what I think I'm going to do is I'm just going to try to multiply this out, and I'm going to FOIL it. So when I FOIL, I get cosecant plus cosecant x cosine x plus cotangent x minus cotangent cosine x. And I'm looking back and I notice I just made a mistake. This term here has to be a subtraction. So now let's go through and do our next step. Let's see. No like terms. But I notice I have cosecants and cotangents all in the same problem. I'm going to convert everything to sines and cosines. This is 1 over sine minus 1 over sine times cosine. Might as well change cotangent to cosine over sine. And once again, change cotangent to cosine over sine times cosine of x. So now I'll notice again, I'm going to look for like terms. I don't think I really have any. So I have 1 minus cosine plus cosine minus cosine squared all over sine, because that was a common denominator in all of these problems. Notice cosine plus negative cosine goes to 0, which leaves me with 1 minus cosine squared over sine of x. And what do you know? 1 minus cosine squared is a Pythagorean identity. That's equal to sine squared all over sine, which reduces to the sine of x, and that is a simplified version of the original function. Okay, we'll do 2 more. It looks like I'm going to have a whole bunch of Pythagorean identities, but before I do that, I notice in this problem, I have a cosine squared in common. I'm going to take and factor. I'm going to pull out a cosine squared. That leaves me with sine squared x minus 1. Now, here's something I know. I know, and I'll do this in another color so we don't get confused, I know 1 minus sine squared equals cosine squared. That's a Pythagorean identity. I almost have that right here. So if I was to pull a negative 1 out of this, I'd have negative cosine squared of x. And pulling a negative out of this sine squared minus 1 term, I have 1 minus sine squared. And I just got done saying that 1 minus sine squared is equal to cosine squared. So this is negative cosine squared times cosine squared. Thus, I multiply those together, and I get negative cosine to the 4th x. And that's the simplified term. All right, let's keep moving here. Let's see, how many more do I want to do? Let me look at these. All right, I think I'm going to do 2 more. So let's do this one. Again, I notice I have a squared term here. I'm probably going to have to FOIL that out. Maybe, maybe not. I notice that I'm going to have a subtraction here. So I'm going to get a common denominator, multiply by secant over secant. Thus I'll have tan x plus 1 quantity squared over secant minus secant squared of x over secant. I can simplify that. This is going to be, I'll FOIL this out now, tan squared x plus 2 tan x plus 1 minus secant squared of x over the secant of x. Now I look at this and I say, hey, wait a minute. 1 plus tan squared, this term right here that I have linked, is a Pythagorean identity. 1 plus tan squared is secant squared. and I have a minus secant squared here plus 2 tan x all over the secant of x. Now, if I know this, I can do some more simplification. The secants go. This is 2. And instead of saying tangent, I'm going to say sine x over cosine x. Over, instead of saying secant, I'm going to say 1 over the cosine of x. Multiplied by the reciprocal, I get 2 sine x over cosine x times cosine x over 1. Thus, this all reduces to 2 sine of x. All right, last one. This one's kind of crazy. Not that crazy, but still. We're going to need a common denominator. Common denominator is going to be cosine and 1 minus sine. So notice what I'm going to do here. I will take and multiply this left term by cosine over cosine, multiply the right term by 1 plus sine over 1 plus sine. And then I'll have common denominators everywhere I need them. So this gives me cosine squared. I have to FOIL 1 plus sine by 1 plus sine. I get 1 plus 2 sine plus sine squared over, I'm going to keep this as a product rather than multiplying it out because I'm hoping something will reduce. So I'll keep it as cosine times 1 plus sine. I notice these two ends are a Pythagorean identity of 1. So I have 1 plus 1 plus 2 sine of x over cosine of x times 1 plus sine of x. You'll notice that 1 plus 1 is 2, and I can factor that out. So I'll have 2 times 1 plus sine x over cosine x times 1 plus sine x. 1 plus sine x reduces, giving me 2 over cosine of x, which can be written as 2 secant of x. Again, getting down your Pythagorean identities is going to be huge. You need to do that quick. And the bottom line, you're going to have to just trial and error on a lot of this stuff. And you may run into a roadblock. You may have to start all over again. But the practice and practice is going to make perfect. All right? Here are your questions to answer for today, and we'll see you tomorrow.